Okay, this is the next type of weld joint that you will encounter, and this is a groove weld. Called a groove weld because it has a large groove cut into it, sometimes both sides, sometimes one side. This is two pieces butted together, but you could also encounter this as a fillet or a T as well. The main thing is it's grooved out. Now, the entire reason for grooving out the weld is that weld rods have a limited penetration into the metal. If the metal is very, very, very thick, and you need to get your penetration down to the very base or bottom of the metal, the only way to do that is you have to groove it out to enable your rod to get down there. That's really what it's about. Okay, so in looking at this, let's look at the parts of this. Let's look at the parts of a groove weld. This is important to know. Again, the red is your weld axis, and your weld axis is always going to move right through the center of your weld, okay? An imaginary line running through the center of the weld joint you're going to be welding. This opening here is called the root opening, and you need that. This is critically important in a groove weld, whether it's flat pieces like this, especially if there's pipe that's grooved. For welding, you need the root opening. Now, why do we need a root opening? Okay, let's go back to our weld rod. Okay, the root opening is equal to the size of the weld rod, the diameter of the weld rod, okay? Because if you need to get the weld rod down in there, you got to have room for it. If this is too small, you can't get your weld rod down all the way to the bottom of the weld joint, and you're going to have discontinuities and lack of fusion down there, and it's just not going to be good. So a quick way to judge is how big of a root size do I need. This is all based entirely on the diameter of the weld rod you happen to be using. So that's what you use to set it up. Whatever rod you got, that's the diameter. Now, another part of this is, a very important part is right over here, this area, you see right here, the point, okay, at the bottom is called the root face, or sometimes it's called land. I've always heard it referred to as the land of the weld. That's this point right down here and right over here, okay? Now, in this case, this is what they call knife-edged, all the way down to the bottom. Now, if we go back to what we've learned about different metals have different properties, like some heat up faster than others, some conduct energy, thermal energy more than other ones, and this is what will determine your root face, okay? Knife edging is required if you're doing, say, if this were stainless steel, knife edging would be absolutely required. Whereas if I were doing a mild steel, okay, I would want a flat spot ground onto this thing, okay, which is equal in size to the diameter of my weld rod. So I lay this down in here, okay, and take a look right close to the camera if we can. I would want a flat spot, okay, grounded the edge that's the same height as my weld rod diameter. So if you think about it, you basically want an opening down here, like a square that's like scribed around the diameter of your weld rod. Now, why do we do that? The reason is because stainless steel, for instance, stainless steel has half the thermal conductivity of steel, which means it takes twice as much energy to heat up. It also takes twice as long to cool down. So, if you have a fat land on there, you're not going to be able to heat up this enough to get proper fusion. Okay, you're not going to get enough heat in there, and the bottom of your weld will have lack of fusion and look really ugly. If I tried to knife edge this, say with mild steel, this edge is too thin and it's going to rapidly melt and burn away, leaving a huge hole. So the root face or land of a groove weld is entirely dependent on the alloy that you happen to be welding at the time. So it's something that does come with experience and comes with learning and a lot of reading about, and asking people, hey, what is the proper way to do this? And doing research. It's not a one-size-fits-all thing. Now, the thickness of the metal, this is your weld size. If it's 3/4 inch material, I have a 3/4 inch weld. There it is right there. Okay, so let's take a look at the parts over here. So right over here, the opening again, this opening is my root opening. Now if you happen to have a backing bar like this has, this is called a closed root. There's also the type where you have an open root, where there is no backing bar and there's just empty space here. This is common for, say, something like if you're welding a pipe, where you cannot put a backing bar inside of a pipe. It's an open root. This is a little trickier, but still it's not that hard to do with practice, and you know, we can do that. But for us testing, we test using a closed root. So this is what we will be doing in the lab. Now, again, this is my weld toe. If you notice here carefully, getting close here, notice that the weld toe is beyond the edge of the actual groove opening of the weld. Now there's a reason for that. We want to go just a little bit beyond, in this case 1/8 of an inch beyond, so that I'm actually filling and sealing this opening. If you go right to the edge here, you're going to end up with undercut and grooves in there. And what you want to keep in mind is any grooves or openings are places where water or salt or any chemical contaminants can get inside the weld groove and cause problems. So you want to seal this thing. You want to cap it off. So we want to always go a little bit beyond, okay? But if you're out here, that's bad. You do not want that. It should not go way out into the heat affected zone. It should be very small, just beyond the weld opening of the groove. Again, the dotted line is our heat affected zone. This zone will be visible as a slightly different color where the steel has been affected by the heat of welding. Again, we want to look at the heat affected zone, make sure it's nice and even, parallel with the weld. If it's all blobby looking and irregular, that means your motion is really irregular and hesitant, or you're stopping and starting, allowing lots of heat to build up in your weld, and it's going to show. So you also, that's a very important thing to look at, the heat affected zone. Okay? And again, so this would be in the flat position. This would be a 1F, flat on the table. We're welding straight down into it. So again, this will be straight down because we're splitting the weld. Okay? And this will be inclined at 10 to 15 degrees, and I'd weld right up like that. Okay? Or if I turn it this way, it would be across like this. That's 1F. 2 would be here. A horizontal weld. Vertical is going this way, which is going up in this position. Again, it would be halfway the angle of the weld, and keeping flat as much as possible, traveling vertically upwards. Overhead would be this, where you're coming in up underneath just like that. Okay? So those are the 4 positions, 1, 2, 3, and 4. And think of it like levels of difficulty, okay? The higher the number, the greater level of difficulty you're going to encounter. Now, unless it's a testing condition where you're required to weld in that position, the smart thing to do is, can you move your object you're welding so that you're in a flat position or in a much lower number? So if you can just like turn the object over, or maybe move yourself into a more advantageous welding position, you're going to have more success. Okay? The higher level of difficulty means you may encounter higher levels of risk for inclusions, porosity, lack of fusion, any number of problems. So yeah, even though you say, yeah, I'm skilled and I could do this, you want to keep in mind that the more risk you take, the greater chance for having something go wrong. So you want to work smart. Okay? So again, how many beads am I going to use here? Keeping our 3-rod rule. This is as wide as your passes should be. So if we're looking at the size of this, this is smaller than the opening that we need to fill. So what this means is, realistically, this would take probably 1, 2 passes to completely cap over this opening, okay? Maybe even 3. I mean, you could do 1, 2, and a third one on top in the middle. That is permissible. However, the height, okay, you may not go beyond 1/8 of an inch, okay, beyond the surface of the metal you're welding. So your cap, okay, your weld face may not be higher than 1/8 of an inch beyond the surface. So you gotta go 1/8 inch beyond, but no more than 1/8 inch over crowning your weld. So you want to keep all these things in mind, okay? These are the kind of regulations that we need to follow. So again, using your 3-rod rule, okay, you can kind of estimate how many passes it might take to fill this up. Now, it's not going to be dead exact. It's a very rough estimation, but I think it's helpful to kind of estimate, like, okay, yeah, I'm probably going to need 6 or 8 passes on this thing, just so you know you've got enough rods ready at hand, and you're ready to go. Because it sucks to sort of be going along, and now you've got to go run over and go find some more rods because you've run out. And by the time you come back, your weld is cooled off, and you know you got to start cold. I like getting the passes in while the weld is hot. You're going to get better fusion. You're going to get a much nicer looking weld. Plus, if the metal can all cool at the same rate at the same time, it reduces your chances of distortion or strange things happening due to irregular cooling. So we want to always think and be prepared. Okay, that goes back to that sort of ideas about ergonomics and setting up our workspace. You know, the work triangle. I have my piece here. I want my weld rods over here. I want my, you know, chipping hammer and my brush over here. Everything at hand, so that all of my parts and pieces are right where I need them, and I'm not scrambling around the lab trying to get stuff that I need. So we want to always do this before we start setting up. So again, these will be the 2 types of joints that we encounter. Okay, now they can be in many different positions, and that governs the positions 1, 2, 3, and 4. Now there are 2 more positions which cover pipe, and those would be 5 and 6. We will look at those later on. Once we're proficient in doing these 2 positions, and at the school, the 2 positions that are required for passing the stick welding portion of the course, which is a big chunk of it, are going to be a vertical this way, okay, a vertical groove, which is going to be a 3F this way, and then an overhead underneath over here. Okay, these are going to be the 2 that are required for passing that portion of the course. So these are the biggies that we want to concentrate on. All right, so that's it.